All right, geometry, we are going to continue our work with Standard 17 with our in-class 73 lesson today dealing with angles with vertices on circles, and a reminder of our standard scale that in order to get to be at a level 1, you need to be able to successfully find 3 of these 7 angles. Okay, 5 of these 7 get you to a level 2, and finding all 7 will put you at a level 3. And then that 4 comes when you can do that and apply properties within the same circle to find measures of missing arcs and angles. Okay, so our in class 73, here we go. All right, so got a page of some terminology and theorems here to start with. So an inscribed angle is an angle whose vertex is on a circle and whose side contains chords of the circle. So it's whose vertex is on a circle and whose sides contain chords of the circle. So in our example here, the inscribed angle would be angle A. Okay. The intercepted arc is an arc that lies in the interior, so the inside, the interior of an inscribed angle, and has endpoints on the angle. Okay, so has endpoints, I think this is has endpoints on the circle, okay? So in this case, the intercepted arc is arc BC, okay? The endpoints of the angle are on the circle, okay? Do you see that? So circle there, okay? The inscribed angle theorem number 1 says, if an angle is inscribed in a circle, then its measure is half the measure of the intercepted arc. Half the measure of the intercepted arc. Okay, so that means the measure of angle B here is half the measure of this arc, AC. Half the measure of arc AC. I forgot the half here. I said it and I forgot to write it. 1/2 the measure of arc AC. Okay. Theorem number 2 says, if 2 inscribed angles of a circle intercept the same arc, then they are all congruent. Okay, so what that means is for the measure of angle B, okay, it's going to be congruent to the measure of angle D because both angles intercept arc AC. See how this angle here, the intercepted arc is AC, and then when you come to here, the intercepted arc on both of them is AC. Therefore, angles B and D are congruent. Okay, theorem number 3 says if an inscribed angle intersects both endpoints of the circle's diameter, then the angle's measure is 90 degrees. Okay, so my vertex is on the circle, okay, and the 2 chords endpoints, so F and E, form the diameter. Okay, so the measure of angle G is simply 90 degrees. Okay, next, number 4, theorem number 4 says if we have a, what's this called? Quadrilateral. if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so that means that the measure of angle A plus the measure of angle C, okay, I should make different marks there because they're not congruent, but together they add to be 180 degrees. Okay, so the measure of angle D plus the measure of angle B, okay, are opposite angles, so they equal 180 degrees. Supplementary means they add to be 180 degrees. Okay, and so that was 4 different theorems for inscribed angles. Okay, and now we have the tangent chord angle. Okay, that says if a tangent, remember that means it hits the graph in one place, so that would be this line here. Okay, and a chord intersect, so here's a chord through the circle, intersects my tangent. Okay, if they intersect at a point on a circle, then the measure of each angle formed is half the measure of the intersected arc. Okay, so that means to get the measure of angle 1, okay, it would be half the arc. So the chord and the tangent line form this arc. Okay, so it would be half the measure of DRB. Okay, and then the measure of angle 2 then is half the measure of this arc here. Okay, all right, so I'm going to zoom out to make sure you can take a second to double check you've got all of that filled in correctly. Okay, so in class 73 terminology here. Okay, make sure you've got everything filled in correctly before we go do a bunch of problems applying what we just learned. Okay, all right, so I would suggest, again, as I did earlier, that when you have parts of circles given, any parts of the arcs or the angles given to you, I just kind of fill in everything that we know. Okay, so, for example, in this first one, since my arc here is 50 degrees, okay, that means my central angle here is 50 degrees. That's previous. Okay, and since these parts of the triangle are marked as congruent, that means they're the same distance, so therefore the arc of 50, it would follow that that is also 50 degrees, which means angle 1 is 50 degrees as well. Okay, now, since I have a radius here and here to form that triangle, okay, that means they're congruent, right? That these two are congruent to each other. Okay, that means in my triangle that these two angles are congruent. So I can take 180 minus the 50 degrees that I have in my triangle, this is for the triangle, gives me 130. And because the sides are congruent, the angles are congruent, I can divide by 2 to get 65 degrees, which is going to be the same on this triangle, right? So angle 2 measures to be 65 degrees. Okay, next one. First thing I know is a circle is 360 degrees around. So if this is 120, to get the measure of angle 2, I can just simply take 360 minus that 120, and I get 240 degrees. Okay. We also know that this 120 degrees, since the vertex is at the center, the arc is the same at 120. And we just learned that this angle 1 we can find by taking half of the measure of the intercepted arc. So 1/2 of 120 will get me the measure of angle 1, and that would be 60 degrees. Okay, and again, we're doing a video, so at any point you can pause the video and try some on your own. So we have 6 more on this page, and then if you turn the page, there's 6 more examples to work through. So if you want to do a couple more and then pause it and try it on your own, feel free to do that as well. Okay? Alright, so I've got 35 degrees here, okay, which means this arc that it intercepts, right, is 70 degrees, okay, because it's half. Okay, so if this is 70 degrees, these have both, actually, we wouldn't have even had to find that because since that arc is there, angle 2 has the same intercepted arc, so I can, angle 2 is the same as 35 degrees. These two are going to be congruent because they share that intercepted arc. Or you could take half of 70, same thing. The measure of angle 2 is 35 degrees. Okay, I know that if I have 90 degree angle here, this is 90 degrees. So to get the measure of angle 3, I can take 180 and subtract the 35 I just found for angle 2 and 90. And I get 55 degrees for the measure of angle 3. Okay, so let's look here. Measure of angle 3 shares this arc with angle 1. See that? So 1 and 3 are congruent. And since I found 3 already to be 55 degrees, I know angle 1 is also 55 degrees. Okay, next one. Ooh, look at that. Remember what those markings mean? That these two are parallel lines, segments, line segments, okay? So 33 and angle 2 are alternate interior angles, making angle 2 also 33 degrees, right? And that's alternate interior angles theorem says that I know that. Okay. This 33 degrees, this angle, has this intercepted arc here, which is the same intercepted arc as angle 1. So angle 1 ends up being 33 degrees as well. They share an intercepted arc. Example E. Okay. My angle here has chords that share an endpoint that go through the diameter, so that tells me that's 90 degrees. Okay. Which means I have in this triangle 180 degrees, which makes angle 1 60 degrees. Right? 90, 30 is 120, and the triangle has to be 180. Okay, so angle 1 is 60 degrees. Okay, measure of angle 2, let's see, shares an arc here, right? See this angle 2 here, and here's the arc, shares with this 30 degree angle. So if this is a 30 degree angle, that tells us this arc measure is 60 degrees, because this angle is half the arc it intercepts, okay? Angle 2 shares that, making it 30 degrees as well. Right, these are both 30 degrees. They share an intercepted arc, so they're congruent. Example F. Again, angle 1 has 2 chords that have endpoints that form the diameter, which makes that a right angle, 90 degrees. And my angle 2 actually does the same thing. two chords that have endpoints sharing that make the diameter. So angle 2 is also 90 degrees. Alright, so here we go. So again, right now, I'm not worried about getting my answers as much as just filling in everything I know. Okay, so here I've got 48 degrees. Okay, which means my arc out here is double that. Remember, my angle measure is half of the arc. So 48 times 2 is 96 degrees for the arc. Okay, what helps with that arc is this angle that has the vertex at the center is the same. So angle 3 is 96 degrees. Angle 2 is half of that 96 degrees. Okay, or you could say angle 2 shares an intercepted arc, therefore it's congruent to this 48 degrees as well. Either way. Okay, so then we've got angle 1 here, so we've got, trying to see how we angle 1 here. Angle 3 we said is 96. I need to fill this in. So 96. Oh, and then we have, that's a radius of the circle, that's a radius of the circle. Okay, which means these two will be split in half after we take that 96 degrees. So 180 minus 96 is 84. Okay, that means this angle 1 and then this angle over here would have to be congruent since it's opposite sides are congruent since it's a radius, right? So divide by 2, making it 42 degrees. Lots of stuff we're using here to find all these missing angles. Okay, H. Angle 1 has the intercepted arc measure of 100 degrees. So to find the measure of angle 1, I take half that arc, 50 degrees. Okay, measure of angle 2. Here's my angle 2. Here's my arc at 60. So to get the measure of angle 2, I take half of the arc, and I get that that's 30. Okay, so I can find this third angle of my triangle now, right? 50 and 30 gives me 80. So 180 degrees minus the 80 makes this angle 100 degrees up here. So what do we know angle 3 is? Also 100 degrees. Vertical angles theorem, right? When two lines intersect. Vertical angles theorem. Okay, so again, not just the new stuff we've been learning with this standard, but we're using some previous knowledge as well. That's just not going to go away on us. Okay? Right, find the requested measures. Okay, so on our first one, again, at any point, now would be a really good time if you have not yet paused it to try it on your own. I strongly recommend that you do that. Okay. All right, so I know my arc here, and I can see angle 1 and angle 3 both share that intercepted arc. The measure of angle 1 is equal to the measure of angle 3. They're congruent, and I can find those by taking half of the intercepted arc, which is 33 degrees. So 1 and 3 are both 33 degrees. Okay, so 1 and 3 are 33 degrees. Okay, so let's find this missing angle here. So 78 plus 33 is 111 degrees, which means that third angle in my triangle is 69 degrees. And again, measure of angle 2 is the same because they are vertical angles. Okay. Next one. filling in everything I know. Let's see. This endpoint, this would be a right angle because it's endpoints of the chords that form it make up my diameter. Okay, if this is 110 degrees, I know x is the same because my vertex is at the center. So that intercepting arc is equal, so x is 110 degrees. Okay, vertical angle, so that would be 110 degrees, right? These are diameters here, which means that arc is 110 degrees. Okay, I also know this is 70 degrees because my diameter here, that's a line, so that's a total of 180, so that's 70. Okay, which gives me arc measures of 70 and 70 as well. Okay, to find the measure of angle 1, its intercepted arc is 110 here, right? It would be this. So to get the measure of angle 1, I take 110, divide by 2. I get 55 degrees. Measure of angle 2 is over here, but my intercepted arc is also 110. So I take that 110 divided by 2 to get that 55 degrees. And the measure of angle 3 shares this intercepted arc of 110, so again makes that 55 degrees. It won't always end up that way, but just oh, here's that tangent chord theorem. Tangent chord theorem says you can take half. So to get the measure of angle 1, it's half the measure of the arc, so of 112 degrees, so 56 degrees for the measure of angle 1. Okay, and if this is 112 degrees, how do we find the measure of x? Well, it's the rest of the circle, right? So 360 minus that 112 gives me 248 degrees. So this arc is 248 degrees, so x. So to get the measure of angle 2, I take half the arc length, so half of 248, which gives me 124 for the measure of angle 2. Okay, again, if you haven't paused it, we've only got 3 examples left, so give it a try. Okay, 48 degrees here. Okay, there are my chords, which means this is my intercepted arc. Okay, remember the angle is half the measure of the arc, so 96 degrees, because 48 times 2. And if that's 96 degrees, angle 1 is 96 degrees. Okay, and I think on mine there's a label missing. That should say 2. So measure of arc 2. So this is arc 2, okay? So if that's 42 and 96, I get 138 degrees. Angle 2, or arc 2, is the rest of it. So 360 minus 138 gives me 222 degrees for the measure of arc 2. Okay, see how you can just kind of start filling in what you see that you can do? Find everything you can. Okay, and then go look at what's being asked if you want. Okay. So on the last 2 examples here, so on E, I know that's 125, that's 143, and I have this one extra piece left. So I'm going to add my 143 and 125, and I get 268. So to find that third arc, I take 360 minus my 268, and I get 92 degrees. Which actually gets us both our other answers. So that tells us that angle 1, because the vertex is at the center, is equal to that. And angle 2, I divide it by 2, so I get 46 degrees. Our theorem says it's half the intercepted arc. Okay. And of course, we're going to have some, has algebra in it. You're going to see quite a few more of these than you are with just the numbers on your homework, okay? So we said when we have a tangent intersecting with a chord at a point on the circle, that measure of that angle, so the 59 degrees, is equal to half the arc. Okay, half the arc. So that means I just need to solve for x. So I'm going to always start, I don't distribute the 1/2. I'm going to multiply this side by 2 so it cancels, and multiply that side by 2. So I've got 118 is equal to 2x plus 34. Okay, if you distribute the 1/2, it's fine. Okay, I just don't want to deal with decimals. Okay, so subtract your 34. So we've got 2x equal to 84. Finish solving, divide by 2, and I get x is 42 or 42 degrees. Okay, and that, I believe, let me double check, it was kind of a lot, wraps up our in class 73. Okay, so that was, here's our second page. If you paused that to give it a try, that blocks some of the light here, make it a little bit darker if that helps, okay? So at least let you get a second to check that. Okay, make sure that you're okay, and you can go ahead and proceed to do the homework.